This is our second part of time per distance videos. Here and in the first video I've covered 7 questions of different types. Now here I will be covering 8 to 13 questions in this second part of the time per distance. Right. So I hope you remember this basic formula, that is distance is equals to speed into time. Right. Now here we can say that speed is equals to distance upon time, and whenever the distance is constant, speed is inversely proportional to time and vice versa. That means time is also inversely proportional to our speed. Here, walking at 5/6 of his usual speed. Usual speed means what? The one that he was having usually. That means just consider this usual speed as S1. Right? And then we will consider this new speed as S2. Right? Because walking at 5/6 of the usual speed, which means this 5/6 of S1, right? 5/6 of usual speed means 5/6 of S1. So this is our S1 and this is our 5/6 of X1. Now a train is 10 minute late. Train is 10 minutes late. Initially, if train is taking t minutes, like when the speed was S1, if our train is taking t minutes, now as the speed is 5/6 of the initial speed, the time is t plus 10 minutes. Right? Time is t plus 10 minutes. Now here, why we are not taking care of any kind of units? Because we are going to use the concept of proportionality here, which means as distance is constant. From this question you can definitely come to the conclusion that our distance is constant in both of the cases. Why? Because here there is no specific mention of different in the distance difference. Here walking at 5/6 of usual speed, a train is 10 minutes late. Right? Here we have to by default it is instinctively considered that our distance is same. Otherwise it would have been specifically mentioned here. So now as distance is constant, we know that S is inversely proportional to T, which means S1 by S2 is equals to T2 upon T1. Right? Now this proportionality can be used in multiple kind of questions where in 3 of them, if anyone is constant, you got to go for the proportionality. Right? If questions can be solved with proportionality, it would be very much easier, you just go for the proportionality. Right? Now initially our speed is S1, right, and time is our T. Time is speed is S1, right? And second speed is what? It's 5/6 of S1. It is 5/6 of S1, which is equals to our T2 is what? T2 is T plus 10, and our initial speed is what? T. Now you may be thinking like that here we just added our 10 minutes to T. Why? Here we are not taking care of any units. Because what, like whether just consider if this is like if whole thing is hours, of whole thing is minutes, in the denominator also this would be like hours or minutes. Just this will get cancelled, right? Therefore we do not need to take care of units here. Similarly for speed also, the units will get cancelled. So here we do not need to take care of our units. It would be directly cancelled. You can just go with the normal basic unit that is given in the question itself. Now just cross multiply this, right? S1 into T is equals to 5/6 S1 into T plus 50/6 10 into 5/6 S1. So this is our equation. Now by solving this equation, first of all just get these terms here, because like the units are same, ST and ST. So S1T minus 5/6 S1T would be equals to 50/6 S1. You can find this S1 as common in 3 of the terms. You can directly cancel this S1. Right? Like from here you can take common out this. You can just common out this S1. It will get cancelled by this S1. Directly you can cancel this out, and then we will be left with T minus 5/6 of T, which is equals to 50/6. So 6 will be like 6 will be at the denominator, that is 60. 60 minus 5t by 6 is equals to 50 by 6. Here we can just simply cancel this 6 out. So 1t is equals to 50. That means our time is 50 minutes. So usual time is our 50 minutes. So our ninth question here. A man walks at rate of 5 km per hour. Then he misses a train by 7 minutes. And if he walks at 6 km per hour, he reaches the station 5 minutes earlier. And then we have to find out the distance between him to reach the station. Consider from his home to the station. Right. Now, as in the previous question, we have used this concept of proportionality. Here also it is similar. Like when we have been given this kind of comparisons, we just have to check first of all if we can use the concept of proportionality, because in most of the cases we can directly use this concept, and we have to then find out the distance covered by him to reach the station. As we know, the distance is equals to speed into time, and our distance is constant here, therefore speed will be inversely proportional to time. Right? Now, if a man is walking at the rate of 5 km per hour, which means our S1 is given as 5 km per hour, our S2 is given as what? 6 km per hour. Consider the usual time taking, the usual time which is required for reaching the station, is t minutes, right? Like for example, like when the speed is 5 km per hour, he misses a train by 7 minutes. Misses a train means what? If he would have come 7 minutes earlier, he would have got the train, which means he has taken 7 more minutes to reach the station than t. If you have got in the 3 minutes, he would have caught the train. He has taken t plus 7 minutes. So here time taken is t plus 7 minutes, and in the second case he reaches the station 5 minutes earlier, which means he has he has reached the station t minus 5 minutes, in t minus 5 minutes. So by using the concept of proportionality, directly S1 by S2 is equals to T2 upon T1. This is our T1 and this is our T2, right? So S1 by S2 means what? 5 by 6 is equals to, and as this both of this is in kilometer per hour, it will get cancelled here, right? Similarly, it is in minute, both of them are in minutes, therefore they will definitely get cancelled. The minutes will get cancelled. You can directly use this. So T2, we need T2, so T minus 5 by T plus 7. If we just simply cross multiply this, we get 5T plus 35 is equals to 60 minus 30. 60 minus 30. Now solving this, 5T minus 60 is equals to minus 30 minus 35. We will get minus T as minus 65. Therefore T is equals to 65 minutes. And remember, so initially we have been given everything in minutes. The time is given in minutes, therefore we will get our time in minutes only. So this T is in minutes only, right? Now what we need to find out? We need to find the distance is equals to speed into time. We need to find the distance, right? And distance is equals to speed into time. So distance is equals to speed. Consider the speed of, you can consider any of the speed, right? You can consider either 5 or 6. Let's just consider 5. And now when solving this, you have to consider the units. Otherwise you will definitely gonna get the answer wrong, because you just cannot multiply hours. If this is in kilometer per hour, this is t minutes, you just cannot multiply like this. You have to take this into 60 to get this. Now this will be converted into hour, right? Now, so which is 5 into, as it is in hour, 5 kilometer per hour into, what is the time taken for it? 5, the time taken is t plus 7. T is 65 plus 7, which is 72 minutes. 72 minutes. As it is in minutes, divide it with 60. This is nothing but we have converted this 72 minutes in in hours. So this is nothing but 12 6s are, 12 5s are, this 5 and 5 is cancelled, so we will get 6 kilometer. It is in kilometer, right? Kilometer per hour, so this is nothing but kilometers. So 6 kilometer is the distance between his home and the station. In this question, this is our 10th question. In this question, we are going to use the concept of relative speed. Don't worry, I'm going to explain what is exactly the concept of relative speed. Like here, A and B are two stations 390 kilometers apart. A train starts from A at 10 a.m. and then travels towards B at 65 km per hour. And another train starts from B at 11 a.m. and then travels at 35 km per hour. And then at what time do they meet? Now, in this type of questions, when we want to use the concept of relative speed, remember this: when the two trains are moving in the opposite directions, their speed will get added. Like when they are, like for example, A is moving in this direction and B is moving in this direction, speed is S1 and here speed is S2. The relative speed is what? It would be S1 plus S2. The speeds will get added. Similarly, when they are moving in the direction which is in the same direction, like for example, A is here and then B is somewhat here and then starts moving, the speed is taken is S1 and S2. Just subtract S1 or S2 or S2 minus S1 based on which is higher, which is greater. But in this kind of scenario where these are moving in the same direction, the speeds will get subtracted, right? Now we know that distance is equals to speed into time. Here, instead of speed, you can use relative speed based on like what is going to be used, whether they are moving the same direction, whether they are moving in the opposite direction. That one we will have to write here. It is S1 plus S2 or S1 minus S2, like that. And time here, this time indicates the time at which they are going to meet each other. This is that time. And distance is nothing but the difference between their positions. Like for example, A is starting from here and B is starting from here. The difference between these 2 points is nothing but our distance. As here it is explicitly mentioned that it is 390 kilometers apart. So our distance is nothing but 390 kilometers. Right? Now, and one important point is that we can consider this relative speed when they are both of them are moving. Not like A has started moving at 10 a.m. and like B started moving at 11 a.m. and for like A like from 10 a.m. we're just going to consider A. No, this is not going to happen, because why? At this 10 a.m. B is not at all left. It is still there. It is still at the B's position. Like for example, A is moving and A started moving at 10 a.m. As per the question, it is given that A started moving at 10 a.m. and B started moving at 11 a.m. But between 10 a.m. and 11 a.m., like for example, like as A has started the moving 1 hour before A has started moving, and for that 1 hour B is still there. B has not yet moved. It is just still there. And in this type, we won't be considering this 1 hour distance covered by A. Am I clear? Why? Because in the concept of relative speed, we have to make sure both of them are moving. At the same time, both of them are moving. So at 11 a.m. as B has started moving. At 11 a.m. B started moving, and the distance covered by A to A from 10 to 11, we have to eliminate a distance, because at that distance, for that 1 hour B has not moved. We have to consider the distance which is covered by A from 11 a.m. Consider like from 10 a.m. A started moving. At 11 a.m. it started, it reached at this point. A started from here. It has reached this point, and then again it is just continuously moving. Here at this 11 a.m. B also starts moving. B also started moving, and it is and it travels towards B, which means they are traveling in the opposite direction, right? So here it is started moving. So we have to eliminate the distance covered by A at this position. So this particular distance we have to just simply eliminate. We will consider the A's distance from 11 a.m. as B has started from 11 a.m. from here, right? Now, so as they are moving in this direction opposite to each other, we will use this one, S1 plus S2, right? So now, as I've told you that we have to subtract this distance what is the distance, what is the amount of distance which is travelled by A from 10 am to 11 am, that is in 1 hour. We know the speed of A is 65 km per hour, which means in 1 hour A has covered 65 km. Am I correct here? Now as A has covered 65 km, we have to subtract the 65 kilometers from the whole distance, right? As A's distance we have to subtract this 65 km, because this is the extra distance travelled by A when B was not moving. We have to consider from 11 am, which means now 390 minus 65, it is nothing but 325. So 325 km is equals to S1 plus S2. What is S1? 65 plus 35, that is 100, into time, which is, this is the time at which they will meet. So this is 3.25 hours is equals to what time? Now at what time do they meet? As they started moving from 11 am, 11 plus 3.25 hours, 11, 12, 13, 14, that is 14.25. So this is our answer. So this is the time where A and B will meet together. This is our 11th question. Here our trains are moving in the same direction. In the previous question they were moving in the opposite direction, therefore we have taken the difference of the distance in between them, right? But like in this case they are moving in the same direction, right? Like for example, a good train leaves the station at certain time and at the fixed speed. So goods train leaves the station from there, consider this is the A, from where a good train is leaving the station at a fixed speed. Consider this as x km per hour, as this is the speed of our goods train. Now the express train leaves the same station and move in the same direction at uniform speed of 90 km per hour, and this train catches up the goods train in 4 hours. Consider A to the entire C distance. Just first of all, in the first scenario where goods trains leave the station at certain time, so x km per hour, it is moving at x km per hour, and it has, after 6 hours an express trains leave the same station, which means for the 6 hours only goods train is moving. Consider this is the point, so this is the total distance which is covered by goods train in 6 hours. Consider this point as B. Am I right? So up to the point B, goods train has moved to the point B. It has taken 6 hours, right? And it is moving at the x km per hour speed. Now an express train, after 6 hours our express train is moving, our express train starts moving, and they have caught each other in 4 hours, which means what? Now A has reached, our goods train has reached at this point after 4 hours. After 4 hours B, the second train, so this is for goods train and this is for our express train. After 4 hours they are meeting each other, which means for 4 hours it has to, it has reached somewhere definitely. After 6 hours a goods train has reached here. Then after 4 hours reaching at this point, and then after reaching to this point, then after 4 hours goods train and express train are meeting, right? So express train has covered the entire distance up to C in 4 hours. Am I correct? And goods train has reached this reach up to C from B in 4 hours, because of course definitely the goods train speed is lesser. Now so let me just repeat this from A to B in the 6 hours. After 6 hours, that is it already mentioned, goods train has reached this particular distance up to B, right? Now at this point express trains also start moving. Then after 4 hours, when this has reached, when goods train has reached B, at this point express train starts moving from A, and it has covered the goods train in 4 hours. So express train has taken 4 hours to from A to C, right? And then from in 4 hours, of course, goods train will cover some distance, which is this distance, that is from B to C. So this entire distance is exactly equals to this entire distance, right? So the distance covered by goods train in 10 hours. So in 10 hours, the distance covered by the goods train, right? Like as we know, the distance is speed into time. So this is our 10 hours and our speed is x. This is for the goods train. And then for the express train, it is for the 4 hours. And so now as 10 into x, here x is our speed for the goods train and 10 is the time, which is a distance. So this is the distance from A to C. So this is the distance from A to C. Similarly, the distance from A to C for the express train would be 4 hours into 90 kilometers per hour. So this is 90, right? So this is 10 10 0 0 cancelled. So x is equals to 36 kilometer. So this is our distance. X is what? It's the speed of the goods train, which is 36 kilometer per hour. So this is 36 kilometer per hour is our speed for the goods train. 12th question here. A thief is spotted by a policeman from a distance of 100 meters. When a policeman starts chase, the thief also starts running, and if the speed of the thief is 8 and that of the policeman is 10, we have to find when the thief will be overtaken, right? Which means that when the policeman and thief will meet each other. Now, in this scenario also, definitely thief and policeman, they are moving the same direction. Here the speeds will get subtracted. But what was the difference between this question and what is the difference between this and the previous question? There, the goods train and the express trains, both of them were moving from the same point. Irrespective of the fact that they were moving from the different, they were moving at different times, but the point from which they were starting their journey was exactly the same. But in this scenario, there is this difference of the distance, right? So in this type of question, if the difference is there, right? For example, like policeman is like here, and thief is here. When policeman saw the thief, policeman has seen the thief, and then both of them starts moving. But there is this distance which the policeman has to cover, but the initial distance, that is t, is given as 100, which is our difference of the distance when we substitute the values in this formula. When we substitute the values in this formula, here this d has to be the difference between the distance. Like in the initial question, it will just much easier. Why? Because definitely if both of them are starting the journey from the same point and they're reaching the same point, the difference, their distance is same. Directly S1 into T1 will be equals to S2 into T2. Am I right? And that proportionality formula, when distance is constant, kind of the same thing was there in the previous question. But here the difference is given as 100 meters. So that difference is here our distance between them, that is 100 meters. And then what is the difference between the speeds? But make sure here it is in meters, and then our speeds are in kilometer per hour. Either you convert the just convert these meters into kilometer by 1000. This is now our kilometer. By 1000, then this is our kilometer, which is 0.1. Now S1 minus S2, 10 minus 8. Why we are subtracting? They are moving in the same direction, and this is the time when they will meet each other, right? So this is nothing but 1 by 10 is equals to 2 into t. So 1 is equals to 20t. Therefore time would be equals to 1 by 20 hours. Am I correct? So 1 by 20 hours means so this is the time after 1 by 20 hours. They will they will meet each other. But here we have to find out the distance that is covered by thief, right? Here this is not that distance, right? Here this is just a difference. Now by using the formula, that is t is equals to st, what is the distance that is covered by thief? What is the speed of the thief? Right, thief speed is 8 km per hour, which is 8 kilometer per hour, and then time 1 by 20 hours. Why this is directly 1 by 20 hours here? This is the time this is the time for which the thief and policeman both are running, right? So therefore this is the time where thief is running, which is 1 by 20 hours. Here the units is already taken care of. Why? Because speed is in kilometer per hour and this is in hour. So distance is 8 by 20 kilometers. So this is the distance which is traveled, which is covered by thief directly. If 4 2s are and 4 5s are, so 2 by 5 kilometer. To convert in meters, 2 by 5 kilometer, that is into 1000 meters. 5 20 25s are, so 250 into 2, right? Sorry, 5 20s are, it is 200 into 2, which is 400 meters. So this is 400 meters is the distance traveled covered by thief. That is our 13th question. Here I walk a certain distance and then ride back, taking a total time of 37 minutes. Right? I walk a certain distance, riding and walking. Right? Consider this. This is time taken for riding to the certain distance. This is our distance, right? And it is the distance which is there for riding and then also walking back. So this is the same distance. And then walking back, this is our 37 minutes. Right. Now if I could walk both the ways, which means TW plus TW, this is our riding and this is our walking. Again, now this is in the second case, this is walking and this is walking, right? So which is equals to 55. Now if we just subtract this, it will get cancelled, or directly 2 TW is equals to 55, which is our TW is 55 by 2. It is 55 by 2. Now 55 by 2 what? Minutes. This is our walking distance. If we substitute the walking distance in this, so 3r plus 55 by 2 is equals to 37 minutes, right? It's a simple question, it is a really simple question. So 2tr plus 55 equals to 37 2s are. What is 37 2s are? 74. So 74. Now 74 minus 55, 19. So 2tr is equals to 19. Therefore our time taken for riding, riding one way is 19 by 2 minutes. But like for the both ways, now riding back and forth, I mean riding here from here to here and then riding back from here to here. For the one just covering the entire distance, we will require 19 by 2 minutes. Now again coming back from that distance, we will require 2 into 19 by 2, that is 19 minutes. I hope you got it. Thank you. Now we will be covering train questions. Entirely train questions would be there in the next videos. So yeah.